1.6 billion people, which is about 20% of the world's population, may lack adequate housing.
But did you also know that bananas could help them?
We firmly believe science merged into architecture is the change needed all around the world to contribute to millions of lives through design.
We have the pleasure to present you our project Vitile.
Quick question. What do a banana, a shrimp, and homeless people have in common? No? Well, you're about to find out.
Nearly 100,000 lives lost to the coronavirus pandemic.
Is also struggling more than ever.
That the coronavirus is spreading through LA's homeless population.
It's more than 160,000 cases in the United States.
America has become the epicenter of the pandemic.
Emerging in late 2019, the COVID-19 pandemic has spread dramatically across the globe and now threatens various aspects of modern society. The relatively fast transition of the virus has challenged governments to develop creative solutions regarding how they will limit the spread of the disease. International entities such as the World Health Organization have published various social guidelines for governments to promote disease mitigation. Amongst these guidelines include aggressive hygienic measures, the reduction of activities in public spaces, and enforcement of stay-at-home policies. However, the most effective policy for reducing the spread of the virus has been social isolation. These effects of these social isolation policies include severe economic ramifications. One of these consequences has been a dramatic increase in unemployment around the world. For example, during the month of April in the United States, northwards of 20 million citizens filed for unemployment, and the unemployment rate rose to 14.7%, which is the highest unemployment rate since the early 20th century during the Great Depression. If economic and social disasters are happening in a relatively economically robust and stable nation like the United States, what kind of effects will this disease have in countries with less robust social and economic systems? And furthermore, how will COVID-19 affect the most disenfranchised and vulnerable groups in these societies?
The breaking news, stay at home. That is the order tonight.
We all need to stay home.
Stay at home.
Stay home.
Quédate en casa.
Located in Central America, Guatemala is a country with a relatively high poverty rate, according to the World Bank statistics, registering 60% of Guatemalans living in poverty or extreme poverty. Indigenous groups are most affected, with almost 80% of the indigenous population living below the poverty line. Considering the high percentage of socioeconomically vulnerable individuals in Guatemala, further economic hardship could produce devastating impacts for these communities. Due to the impact of the COVID-19 pandemic, the Guatemalan economy is expected to register a decrease in 1.8% of their 2020 GDP, which ultimately could translate into a 1.6 million unit housing deficit, according to Habitat for Humanity. Housing in Guatemala presents deficiencies in both inefficient use of materials, small home dimensions, and a high number of occupants per home. Furthermore, the dramatic prevalence of income inequality, where an estimated 260 Guatemalans own more than half of the country's wealth, suggests that individuals in poverty will have less control over their living situation in the months to come. Wage workers are disproportionately affected by the mandatory stay-at-home orders, reducing their ability to pay rent, buy food, and support their families. Ultimately, homelessness is an anticipated issue expected to expand within the coming months of the pandemic. We propose the construction of temporary housing units by implementing the use of banana palm fibers to create a glycerin-based bioplastic structure. These design characteristics are sustainable, low in production cost, and improve structural stability and hydrophobic resistance, which will be especially important during the onset of the wet season. Our project aims to address the emergence of homeless individuals caused by the post-COVID economic crisis, as well as a temporary solution to the lack of shelter in the face of a crisis such as the pandemic. Given the gravity of the impact this pandemic could have on Guatemala's vulnerable population, this is an opportunity for Guatemala to be a leader in social policy implementation and sustainable solution development. Our proposal might offer a temporary solution to a greater societal issue in Guatemala, but our group believes that using dire situations to address these larger issues through improved design, technological innovation, and ingenuity are qualities that will lead us into a better and brighter future.
But as COVID-19 came into the picture and the whole world went bananas, we thought it was time for us to go bananas as well.
The pandemic is a relatively recent event, but it has come to change the world in many ways. New concepts were created. pre-COVID and post-COVID stages.
Guatemala has high poverty and inequality rates, which results in deficient living situations. Through the first stage, the goal was to provide our country with better building materials, which were far more accessible to low-income households. Given the complications we're living and the big challenge ahead, we decided to create through innovative design and materials.
When COVID-19 became a game changer, we wanted to impact on all that lives that were strongly affected by the deadly virus. So we analyzed two different alternatives, biodegradable separation screens and affordable temporary housing related to our main problem.
We went bananas and concept was created to develop a high-resistant bioplastic by incorporating banana fiber reinforcement so it can be used as a building material in the face of a crisis.
Why we went bananas was not as bananas. Studying the material, we found out that it has a superior resistance than bamboo. On top of that, its tensile strength, elasticity, and rigidity provide a suitable material for its movement and constant use. Natural acids or jute can be also added to increase capabilities. The material needed is extracted from the pseudostem of the banana tree.
The placement of the fibers in our material was inspired on the claws of the Mantis Shrimp, which are formed by layers that contain a laminar rotation. As a result, they get a much greater resistance compared to other materials, making them durable and resistant to heavy loads. Now wonder, how does cross lamination work? Fibers are to be laid rotated on their axis and create cross angles. The resistance of the material is increased, providing tensile strength in different directions and increasing its load-bearing capabilities.
The process. First, the non-useful material is removed from the banana palm by scraping until the fibers are loose and dry. Afterwards, they are detangled and cleaned for later use. Fibers of a similar size and characteristics were selected to achieve a homogeneous sample.
Vegetable glycerin as plasticizer and starch for flexibility are the main materials used in the bioplastic. Even though we didn't use it, sodium can be added to increase the resistance. Several organic-based materials are added as well, to help the resistance towards the composition. The residue from scraping is also added. The material is later kept in the center, inside the mold. This retains the shape and size using the renewable solar energy. Upon reaching a thick consistency in the bioplastic mixture, a layer of the material is placed in the mold. Over the first layer, the fibers of the banana palm are placed so that they are arranged in an orderly manner. Fibers are later placed, creating a cross-lamination.
The final result is the creation of a leather-looking, completely natural material. It's capable of resisting moisture, rain, and tear. Some tests were performed. Sadly, given the global situation, we weren't able to test it thoroughly.
There are many ideas to which we could have resorted for the usage of our material. We went bananas with the ideas. As you can see, all these things are possible. Bags and bags on plates, eating utensils, and degradable furniture. Your sleek leather jacket or a trendy iPhone case. But we decided to get into a route which could change the world.
And finally, we came up with the ripe idea. We present a design of temporary housing.
Using the banana tiles, a rigid structure was designed, keeping the triangle as the base unit of the composition.
This can benefit all those who do not have a decent home in times when having a roof or an isolated space can be critical to safeguard life and human health.
A versatile design that provides thermal comfort, mobility, and easy portability contributes to the health of millions of people who don't have a home to stay safe in.
It is built by using bamboo structural bases and assembled with reusable metal couplers. This being at the same time a temporary refuge with almost zero ecological impact and low cost.
A building kit for the homeless. It includes the structure and mat, a bag, plates, and eating utensils to help people who are in distress given the homeless epidemic we're living.
The use of materials mentioned before offer a variety of options in design and scale.
This proposal will help millions of people around the world. Proximity and fast response is needed because our project could help in the face of different kinds of crises.
The highlighted zone of the map are all the different countries we can provide the fibers need and could easily give the raw material at a very low cost.
Because we intend to have minimum ecological impact, the raw material is extracted from the waste that large plantations otherwise burn. When the tiles are made, the construction of temporary buildings is done and transported within a medium radius. After it has reached its useful time, most of the structure is either compostable or reusable.
We are changing the world one banana tree at a time, and we find it quite appealing. This was our Biodesign Challenge presentation from Universidad del Istmo de Guatemala. Our names are Pilar Mexicano, Karen Pineda, and Luis Eduardo Gordillo.